This is geometry. We're going to go over our trigonometry -3 homework. Let's jump right in. This is going to be using law of sines and cosines, but now I'm not going to tell you what they are. So the first thing that I noticed about this problem is that I have 3 side lengths, a total of side lengths that are known and unknown. Even though this x is unknown, I'm going to consider that part of the count. Because of that, I'm going to be using the law of cosines, and because I only have one angle, I have to use the law of cosines. Otherwise, I would much prefer law of sines. A law of cosines essentially states that the opposite to the known angle, in this case the x, is going to be squared. That's going to be equal to the other 2 side lengths squared, basically Pythagorean theorem, 8 squared plus 10 squared. And then you have to subtract a little bit to make room for the fact that this is not a 90-degree angle. You have to subtract 2 times these 2 angles, 2 times 8, or not angles, these 2 side lengths, 2 times 8 times 10, and then times cosine of that angle, cosine of 23. And again, that cool fact, if this was a 90-degree angle, cosine of 90 is 0, and that whole term would be eliminated. It would be Pythagorean theorem. Moving on, we just basically need to solve. So I've already stated before, because we don't know cosine of 23, we're going to be using a calculator. And since we're using a calculator, you can just type that all in. So that's what I'm going to come do over here. I'm going to go to desmos.com/scientific. We're going to minimize that. If you want a cool recipe, there it is. I'm going to type in 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 23. Make sure we're in degrees. We're in radians now. Now we're in degrees. Hit enter. Okay, there is the right-hand side of our equation. So I mean, I can write that down. It doesn't really matter. I can come here and say yes. X squared is indeed equal to, okay, I have to like zoom in, otherwise my handwriting gets terrible when I zoom out. I mean, it's already terrible when I zoom in, but it'll be even better. So x squared is equal to 16.719. But the cool thing about writing this, that is a 719. Cool thing about having this in the calculator is I can just take the square root of the previous line. The way that I do that with Desmos scientific calculators, you type in SQR, and as soon as I type in the T, boom, square root symbol. And I could type in 16.719. I would get a pretty close answer. But you can just type in ANS. AN, as soon as I type in the S symbol, boom, it takes the previous answer. And I have an exact answer. It's 4.0889. But rounding to 3 decimal places, this 8 right here is going to be rounded up to a 9. So 4.089. So come over here. X is equal to 4.089. I guess I did kind of skip over why are we taking the square root. We're taking the square root of both sides in order to cancel out this square to just give us x. So maybe I'll leave that square root symbol in for the permanent answer key. All right, so that was our first problem. I'm going to be needing that calculator in a sec, but I'll come back to it when I need it. Moving on to example number 2, or problem number 2 rather. We're solving for theta, and this time notice that we have 2 angles. We have 61 degrees and theta. Again, I'm counting unknown with the known. And we have 2 side lengths. This is a perfect case of using law of sines. In fact, you cannot use law of cosines because we're missing a 3rd side. You need all 3 sides for law of cosines. So law of sines basically states, and I'm going to put the sines on the top for this problem. If you don't, you're just going to have to get them. Actually, you know what? I'm going to choose the harder case. What if you did the totally the hardest way possible? You do 21 over sine of its opposite angle. Well, 21 is opposite of theta. Again, I'm drawing this line all the way across. Sine of theta. And that's going to be equal to 19 is the other side length. A little bit of lag there. All over sine of its opposite angle. 19 is opposite of 61 degrees. So sine of 61 degrees. And now we're going to solve for theta. There's a few different ways of attacking this problem. Some people immediately cross multiply, and you are correct when you cross multiply. That is the brute force attack that will definitely get you the answer. But I'm going to do it the more elegant way. Instead of cross multiplying, I instead am going to take the reciprocal of both sides. I'm going to flip both the left and right fraction. When I do that, I'm going to get sine of theta in the numerator and 21 in the denominator. On the right hand side here, you can already see I'm going to get sine of 61 in the numerator and 19 in the denominator. When I do that, I get the theta in the numerator. That's why I did it. Once your unknown variable is in the numerator, it makes the problem much easier to solve. From here, I'm going to get rid of this divide by 21. The inverse operation of divide is multiply. So I'm going to multiply the left-hand side by 21, multiply the right-hand side by 21. When I do that, these 21s are going to cancel each other out, and I'm left with just that bit of lag here. Just that sine of theta is equal to, and I'm going to give myself some room here. I know it's about to happen. That's going to be 21 sine of 61, all of that over 19. All right, now the last thing that we need to do is we need to get rid of this pesky sine, and then we'll get theta by itself. The only way to undo sine is to take the arc sine. I like writing out arc sine like this, but if you prefer writing arc sine as sine to the power of -1, those are the same thing. Maybe you can save some time by using that notation. I don't like it though, because -1 doesn't mean undo. It usually means flip it from what I know, so I like this notation better. All right, arc sine of the right, because whatever you do to the left, you must do to the right. We're taking the arc sine of both sides. When you take the arc sine of sine, they cancel each other out, and that gives you just the theta. And why do I have so much lag on this computer? It's supposed to be brand new. Come on. And then I just basically need to type all of that in the calculator, and I'll get my answer. So coming over here, and I'm going to get arc sine of this fraction 21 sine of 61, and that's all divided by 19. We are in degrees, 75.16. Okay, this number right here is going to be rounded up, because I always round to 3 decimal places everywhere, in class, out of class. 75.169. 75.169. And this is probably being a little bit pedantic, but it's not exactly equal to that. We did round to 3 decimal places, so I'm going to use this approximately equal to sign instead of the equal to sign. And I should have done that up here as well. It's not exactly equal to 4.089. It is approximately equal to 4.089. And again, I'm going to box both my answers. Let's zoom out to size. There is the homework. If you have any questions, just leave them in the comment section, either on YouTube or on Google Classroom. I'll see them, and I'll see you guys later.